All right, in today's lesson, we are going to look at limiting reactants in this video. And in the next video, we're going to look at percent yield. And we're going to see in that second video how limiting reactants is related to percent yield and how we can put it all together in one problem. So I'm going to start off with an analogy. If we are trying to make a turkey sandwich, and we have this recipe here for a turkey sandwich, and we want to make 10 turkey sandwiches, but we only have 18 slices of bread, then the bread is going to be considered the limiting ingredient because it's only going to allow you to make 9 sandwiches. Now, the same thing can happen in chemistry, where one of your reactants limits how much product can be made. That reactant that does the limiting is also sometimes called a limiting reagent, and it is completely used up in the reaction. And then the excess reactant or excess reagent is the reactant that still remains. There's still some of this left once the limiting reactant has been used up in the reaction. So when we are trying to solve these limiting reactant problems, the stoichiometry here is not going to be any different than what we've already been doing. But what you're going to see is that it does take more time to do. You are doing more stoichiometry. Sometimes you're even going to be doing more molar mass problems with this. So I have here just a series of steps that you should do and take in order to solve these limiting reactant problems, and to also make sense of your answers. What are your answers telling you? So the first thing you want to do is make sure that you write a balanced equation, or that the equation that's been given to you is balanced. And you're also going, after that, you're going to set up 2 separate stoichiometry problems. And for each reactant, calculate the amount of product. If the product that is not specified, where the problem doesn't state you're looking for product X or you're looking for product Z, you pick the product, okay? And you stick to using that same product for both of your 2 stoichiometry problems. Now, some of these problems are going to be mole-to-mole problems, and some of these are going to be gram-to-gram problems. And I'm going to solve an example of each one of those. The smaller answer of those 2 stoichiometry problems indicates, first of all, your limiting reactant. You're going to look back to that top left corner of your train tracks to find the formula of that limiting reactant, that limiting reagent. And your actual numerical answer is the amount of product that could be made. And once again, the problem will let you know if you should solve for product in moles or should you solve for products in grams. All right, let's start off with an example problem. And we will go ahead and start off by working a mole-to-mole limiting reactant problem. All right, calcium hydroxide reacts with hydrochloric acid according to the following equation. Now, you have spilled 6.3 moles of hydrochloric acid, and you put 2.8 moles of calcium hydroxide on it to neutralize that acid. Which substance is the limiting reactant? So as always, very first thing you do is to decide, do I have a balanced equation? And yes, you do for this one. The next thing you're going to do is go ahead and solve your 2 mole-to-mole stoich problems using each reactant in each one of your problems and making sure you use the same product. So I'm going to put in some more space. All right, so let's get started. So for this particular problem, we're going to go ahead and write our knowns and our unknowns. We have 6.3 moles of hydrochloric acid, HCl, and we have 2.8 moles of calcium hydroxide. All right, and notice for this particular problem, they did not give us a particular product that they wanted us to solve for. So I went ahead and decided that I was going to solve for the number of moles of H2O. Now, because I was given my reactants in moles, that is why I'm going to solve my product in moles as well. So let's go ahead and set this up. So you are going to have, and I'll put it in a different color, start off with the 6.3 moles of hydrochloric, and set up our tracks. And we'll go back up to our balanced equation, and we will see that we have a 2 for the hydrochloric. So I'm going to put my 2 there. So this way I have my mole ratio, and I'm going to solve for water. Okay, so I have a 2 moles of water. And so I have my problem set up, and moles of hydrochloric will cancel out moles of hydrochloric. And the final answer, once you do some punching and crunching, is going to be 6.3 moles of H2O. Now, that really doesn't tell us anything yet, because we need to do another stoichiometry problem. And this time we're going to do the calcium hydroxide. So we are going to say that we start off with the 2.8 moles of calcium hydroxide. Once again, I'm going to go up to my balanced equation, and we see that I have an understood 1, and I'm going to use that 2 for the water as well. So 1 mole of calcium hydroxide, and then we have we have 2, erase that, and then we have the 2 moles of, not that, try it again, of water. Once again, you're going to put that in your calculator, and you come up with 5.6 moles of H2O. Okay, remember we said we're going to use the smaller amount. Okay, so this is our smaller amount of product made. Okay, and so that means, and you know what, I'll use this. That means the calcium hydroxide, oh goodness, it's huge. That means the calcium hydroxide is our limiting reactant. So if we scroll down just a little bit, our limiting reactant is going to be the calcium hydroxide. And then our excess reactant, which are we still going to have some left of, is going to be the hydrochloric acid. Okay, and how much water was produced in this reaction is going to be 5.6 moles of water. Okay, so that's how you would work a mole-to-mole problem. Let's look at how to do a mass-to-mass problem. So let's see here, we'll go with that, and we will go here. All right, and let's go ahead and read our problem. So when 0.855 grams of chlorine and 3.205 grams of potassium bromide are mixed in solution, which is the limiting reactant? How many grams of bromine are formed? So notice in this problem, they do ask about a specific product. So we do need to solve for that particular product. In this case, it's bromine, the Br2. Now notice we're starting off, our knowns are going to be in grams and what we are solving for in grams. So we have 3 molar mass problems that we have to solve for before we ever set up any train tracks. So let's go about doing that. Okay. So let's see here. We have chlorine. You know what? Let's change that. And let's go green. All right, so the chlorine, remember it's Cl2, so that's 2 times 35.45. Don't forget that's the masses of that element off the periodic table, and that ends up equaling 70.90. And then we also have potassium bromide. So that's going to be K and bromine. And we have 1 of each of those, so that's going to be 39.10 added to 79.90. And you're going to come up with 119. And last but not least, let's solve for the bromine. Once again, it's a diatomic. And so we have 2 bromine atoms, and bromine has a mass of 79.90. We multiply that by 2, and you come up with 159.80. Okay, so here are all the molar masses that we are going to need in our problem. So let's go ahead and write down some of the information that's been given to us. So we have our knowns, and we're going to have a decent amount of knowns for this when we're doing these limiting reactant problems. We have 0.855 grams of chlorine, and we also have 3.205 grams of potassium bromide. And what are we solving for in this problem? We're solving for how many grams of bromine can be produced. So let's go ahead and set up our first stoichiometry problem for this. So we're going to go from 0.855 grams of chlorine Next thing we're going to do is the molar mass of chlorine, which is going to be 70.90 grams of chlorine in 1 mole. Then the next thing you're going to do is your mole ratio. So if we look back at your balanced equation, which we will look at real quick, okay, we see that we're going to have a 1-to-1. Okay, so we have an understood 1 at the chlorine and an understood 1 at the bromine. So let's put that in. 1 mole of chlorine and 1 mole of bromine. And the next thing we'll do is the molar mass of bromine. So in 1 mole of bromine, you have 159.8 grams of bromine. Br2, Br2. All right, and once again, you're going to do lots of punching and crunching, and you should come up with 1.93 grams of bromine. Once again, we don't know if this is the right answer or not. We have to do that second stoichiometry problem, this time starting with potassium bromide going to bromine to determine what is the actual amount of bromine that can be made. All right, so let's put a little bit more space in. And let's go with a different color. And we're going to go ahead and start with 3.205 grams of potassium bromine. And our molar mass of potassium bromine is going to be 119.00 grams for every 1 mole of potassium bromide. And now we're going to do our mole ratio, so we can come back here and let's see what our coefficients are. So potassium bromine has a coefficient of 2, and the bromine still has that coefficient of 1. All right, so we're going to put a 2 moles of potassium bromine at the bottom and 1 mole of bromine up at the top. We got to keep going because we got to solve for grams of potassium bromine. So let's do the molar mass. 1 mole of bromine has a mass of 159.8 grams. Once again, put that in your calculator and you should come up with 2.152 grams of bromine. Now, once again, notice that I modeled my answers on significant figures, okay? So we have 3 sig figs here in that grams of chlorine. And we have 4 sig figs in this mass of potassium bromide. All right, so now let's determine what is our smaller amount. So what we see is that this is our smaller amount. Therefore, the chlorine is going to be our limiting reactant. So our limiting reactant, I'm going to just write it up at the top, is the chlorine. The excess reactant or excess reagent is the potassium bromide. And how much bromine is formed? It is 1.93 grams of bromine. All right, and I think that is where we're going to end this lesson. Yep. And the next video is going to show you about percent yield and how that relates to limiting reactants. And then I'm going to work the first example problem, the first problem in your classwork for today.